All right, welcome back. So today we are going to be talking about how to multiply and divide within scientific notation. If you are using the Big Ideas Blue Book, this is section 10.7. This is going to be tied in with adding and subtracting within scientific notation. Within multiplication and division of scientific notation, we're going to be using a lot of our exponent rules today. So it's going to be a good refresher to think about our rules within exponents. But the reason why we use scientific notation is because often in science and math, we need to not only be able to write really large and small numbers, but complete calculations with them as well. We have been seeing numbers being used, for example, like 4.2 times 10 to the negative 7th. That's a really small number. Likewise, if we have 3.9 times 10 to the 12th. That's a really big number. So we use scientific notation to simplify our calculations and make it easier on us in order to operate. So let's talk about how we're going to be able to multiply within scientific notation. So here are 4 problems that we are going to be talking about within multiplication. So please pause the video and then copy these 4 down. You can notice that the upper left-hand corner is going to be a review problem. So we're going to be reviewing how to just multiply integers and variables with exponents, and then we're going to be applying these concepts into multiplying in scientific notation. So please, again, pause the video, copy down these 4 problems, and then resume when you're ready to move on. All right, if you listen to my voice, that means you're ready to move on. So let's just review our rules within multiplying exponents or just integers in general. We have 4 times y squared times 5 times y to the 5th. We know we can multiply the 4 and the 5 together. Those are integers. So we're going to multiply 4 and 5. Likewise, we have y squared times y to the 5th. So we're going to be multiplying them together. So let's just start to jot down some things that we're doing. So we're doing 4 times 5, and we all know that's 20. So now we have y squared times y to the 5th. Think back to our exponent properties. When we have the same base, which is y, and they're raised to an exponent, when we multiply those bases, we add the exponents. So our final answer becomes 20y to the 7th. Because again, 2 plus 5 is going to give us 7. So we had exponent of 2, exponent of 5, 2 plus 5 gave us 7. Awesome, cool. Let's translate that over into how we work within scientific notation. On the right-hand side, we have 4 times 10 squared times 5 times 10 to the 5th. Well, it's a very similar setup here. We're in scientific notation, it's just we just don't have the parentheses, right? We have these 4 times 5, which is just like we did before, and then we have 10 squared and 10 to the 5th. Notice the 10 has exponents, so we're going to be using our exponent properties here. So let's simplify. 4 times 5 is going to be 20. We're going to rewrite it as times 10 squared times 10 to the 5th. Whoop. I forgot to highlight. Whoops. So 4 times 5 is 20, and I should do it over here as well. So if we're going back to the right-hand side, we have 10 squared times 10 to the 5th. We could just do 10 times 10 is 100, and then 10 to the 5th, which is, oh snap, that's 100,000. Okay, but those are going to be large numbers, and we're going to have to simplify it back anyway. So what we can do is use the same properties we used on the left-hand side with the y squared times y to the 5th and use it in this instance. Well, we have 10 squared times 10 to the 5th. It's the same base, so we're going to add the exponent. So we get 20 times 10 to the 7th. Right? Now, this isn't technically written in scientific notation because 20 is bigger than 10, right? But this is how we apply these properties. If we wanted to have a final answer, it would be 2 times 10 to the 8th. Notice how I had to move the decimal over once to the left, which means I had to add 1 in the exponent. So now I get 2 times 10 to the 8th. Awesome, sweet. Now let's take this and apply it within our operations of what we traditionally see scientific notation written as. So let's highlight again. Nope, that's not what I wanted. Thank you. So we have in the bottom left, we have 4.2 times 10 to the 9th times 5.3 times 10 to the 6th. So we're going to be multiplying 4.2 and 5.3 together. I'm going to put that there. Then we have 10 to the 9th times 10 to the 6th, right? But remember, when we multiply exponents, we keep the same base and we add the exponents. So it's going to be something that's going to look something. Let me try and set us up here. Haha, sweet. So what we're going to do is we're going to do 4.2 times 5.3. Let's see what we get. 4.2 times 5.3. And we get 22.26. We get 22.26 times, again, 10 is our base, and we add the exponents. 9 plus 6 is 15. Now, 22.26 is not in scientific notation. So what we need to do is we need to move this decimal place once to the left to get it between the 2 and the 2. So we have to add 1 to our exponent. So our final answer is 2.226 times 10 to the 16th. Again, that came from multiplying 4.2 and 5.3 to get 22.26. And then we keep the same base of 10 and we add the exponents. 9 plus 6 is 15. But since 22.26 is not in scientific notation, we had to change it into scientific notation by moving the decimal place once to the left. When we move the decimal place once to the left, we add 1 in the exponent. Think of it as doing the opposite. If you move left, you're going towards a negative standpoint, so we add for the exponent. If we have to move the decimal place right, we're going in a positive direction, which means we have to subtract 1 in the exponent, or subtract the amount of places we have to move. Awesome, sweet, cool, smiley face. All right, let's move on to the right-hand side now. We have 3.21 times 10 to the negative 5th times 1.03 times 10 to the 3rd. We're going to multiply 3.21 and 1.03 together. That's going to go right here. Then we're going to multiply our base of 10 to the negative 5th and 10 to the 3rd. That's going to go right here. And we're going to add the exponents. It's going to go somewhere right there. Let's see if we can make it fit now. We have 3.21 times 1.03. That's going to give us 3.3063 times 10 to the negative 5 plus 3 is negative 2. Since 3.3063 is in scientific notation, we are all good, and this is our final answer. Sweet. Nice. Awesome job, folks. Here we go. Let's move on to division now. Now, division is going to apply the same exponent rules as before. So let's just get right into a quick review. In the upper left-hand corner, we have 18 times y to the 6th over 3 times y squared. So we're going to go back to our rules of division. We have integers, or just our traditional numbers. We have 18 over 3. We're going to divide 18 by 3. Our answer is going to go there. And then we're going to have the same base of y. And when we divide our exponents, we subtract. They have the same base. So we're going to be doing 18 divided by 3 is 6. We keep the y. Oh, the green didn't pop up. Come on. There we go. And then we do 6 minus 2 to get 4. So we have 6y to the 4th as our final answer. Sweet. Let's move on to the right-hand side. Let's expand now. Instead of y, let's use a base of 10. Well, again, we're going to do 18 divided by 3. We're going to have a base of 10. And we're going to subtract the exponents. So we have 18 divided by 3 is 6. We're going to fill in the times symbol or the multiplication symbol. Our base is still 10. The base doesn't change. But we have 6 of them in the numerator and 2 of them in the denominator. So that means 2 of them cancel out. 6 minus 2 is going to be 4. So we get 6 times 10 to the 4th. Sweet. Let's take these two and apply them within 2 examples within scientific notation. Pardon me. So we have 8.4 times 10 to the 3rd over 4.2 times 10 to the negative 2nd. We're going to take the exact same properties here. We're going to do 8.4 divided by 4.2. Our base is still 10. And our exponents are 3 and negative 2. So let's see what happens. Let's fill in the colors first. So nice. Cool. So we do 8.4 divided by 4.2. That's easy for us. We just get 2. We fill in the multiplication symbol. Our base stays as 10. And now we do 3 minus negative 2. It's not 3 minus 2. This is a negative sign, so it's going to be 3 minus negative 2, and we get 5. 2 times 10 to the 5th, that is written in scientific notation, so that's our answer. We don't need to convert at all. Sweet. Nice. Now let's move on to the right-hand side. We have 1.5 times 10 to the negative 3rd divided by 7.5 times 10 to the 2nd. Now, this isn't written as a fraction, and we typically want to write scientific notation of division as a fraction. So let's rewrite this. We're going to have 1.5 times 10 to the negative 3rd over 7.5 times 10 to the 2nd. So now let's use our properties here. We're going to divide 1.5 and 7.5. I'll put that there. Our base is still 10. And we have negative 3 in the numerator and 2 in the denominator. So we're going to do 1.5 divided by 7.5. And we get 0.2. I already see something that we're going to have to do, and I hope that you notice it as well. Our base is still 10, and we have negative 3 minus 2. So we get negative 5. But now notice, I have 0.2 times 10 to the negative 5th. Is that written in scientific notation? Nuh-uh. So we need to move the decimal place once to the right-hand side. If I'm moving it to the right, that means I need to subtract 1 in the numerator. Sorry, not in the numerator, in the exponent. Okay? Think about this is going in a positive direction, right? This is like a positive direction, and we have a negative direction. So they offset. Offset! So now we rewrite our final answer. We get 2 times 10 now to the negative 5 minus 1 is negative 6. And that's our final answer. All right, folks, that's how we multiply and divide within scientific notation. Thank you so much for checking in. You're doing so well with this. If you have any questions, please reach out, and we'll get back to you as soon as you can. Have a great day, everyone. Stay safe. Miss y'all. See ya.